Okay, good evening. My name is Mike Curran, and I am going to be showing you my temperature sensor project. Okay, so we're using the DHT sensor that came right out of the box. That's digital humidity and temperature sensor, and of course, we're just using the temperature sensor in this use case. Okay. First for the setup. We are initializing a timer for interrupts, and the timer is in microseconds. Now, you'll notice that it is 5 microseconds, or 5 seconds, I should say. I'm converting from microseconds. The reason for that is I noticed that by putting in 10 seconds, that the interrupts would only go to 8. I think there's a an overrun of some sort of parameter. I think the clock frequency is too high. We need a divider in there. To be honest, a quick fix was to just call the interrupt every 5 seconds and to only process data every second interrupts. So that's why you'll see the count right here. Remainder 2, we actually do the signal processing. Otherwise, you ignore the interrupts. Not the cleanest really way of doing it, but it's kind of a quick and dirty way of kind of getting around the problem. I could have sort of figured out how to get the frequency down for the clock, but thought this was easier, so went with this. As we can see on the main loop, I am just reading the pin all the time in the loop, constantly reading that data. And I'm only processing every 10 seconds. Here is my timer. I am counting up 10 seconds to keep track of the time, and I print it out. Then I'm doing my conversion from Celsius to Fahrenheit, and printing that out as well. That's essentially it. There's not a whole lot to this project. And I will go ahead and show you my results, which are here. Okay. As you can see, I had a constant reading of 75 degrees Fahrenheit. And one more thing I did forget to mention was for the sensor calibration, I am subtracting by 2.1 degrees Celsius. This DHT sensor is outputting in Celsius. So minus 2.1, that's what I used to, I found that it was giving 2.1 degrees Celsius too high. And I based that off just my house thermostat. Didn't do anything too intricate here. So yeah, back to the actual data. All right. So I just copied and pasted this right from a serial output. As you can see, I am just getting constant reading of 75, very level state. Actually, what happened here for a while was that there's a good 5 minutes of data you're getting that it's not real data. It's actually just when I unplugged the sensor and the buffer was not updating. So you kept getting the 75 degrees Fahrenheit. Okay, now when I brought it back from the fridge after 5 minutes, this is real data right here. And you will see, let's go ahead and show you the plots, which is some right here. I apologize. Here it is, disappeared on me. All right, there it is. So here is it's my very first data point after leaving the fridge. At 360 is 5 minutes. So this is really supposed to win. I let it go on for another minute or so. So yeah, it actually didn't come to a equilibrium. As you can see, I imagine if I kept this, it would eventually go up to 75 back to room temperature. But after 5 minutes, actually was not enough time for the sensor to come back to equilibrium with room temperature. Start off actually below freezing temperature, which is interesting. So I don't know what this temperature is rated to, but it was able to go below freezing, which is impressive. So yeah, that's really about it. Thanks for watching my video. Good night.